I wanted to continue on. The first video is actually 1 through 11, so I want to start off here with number 12. Again, this is a fraction, so what I need to do is find a common denominator. Before I can find a common denominator, I need to factor any denominator that will factor. X squared minus 4 factors into x plus 2 and x minus 2. That is actually my common denominator. So I'm going to multiply each fraction by the common denominator. And as I did in one of the earlier problems, I am going to divide out my denominators and then multiply the factors that are left. Divide out x minus 2, bring down 5, x plus 2, and then on the right side, both factors divide out, so I end up with 8. Now the rest of this question, distribute, combine like terms, add 16 to both sides, and divide by -2. So I end up with x is -12. In order to undo a square root, square both sides. On the left side, the square and the square root divide or cancel each other out. On the right side, I end up with x squared. Set this equal to 0 and factor. Factors into x minus 5, x minus 1. Therefore, I end up with x is 5 and 1. When you're working with square roots, you need to make sure that if you take the solutions and substitute them back in, that you do not end up with a negative, since the square root cannot be negative and you cannot take the square root of a negative. In this case, if I substitute the 5 or the 1 in, I end up with positive values. So both of them are possible solutions. Now for number 14, you want to get x alone, and in this case it's x to the 1/3 alone. So I would add 4, divide by 3, so I get x to the 1/3 equals 4. Now x to the 1/3 really means cube root. In order to undo a cube root, we would cube both sides. So x is 64. When you're finding a vertical asymptote, if anything will factor, you need to factor it. So the denominator is a difference of two perfect squares, so it factors into x plus 3 and x minus 3. The x plus 3's will divide out. Since everything in the numerator divided out, we put a 1 there to hold the place, and then in the denominator we're just left with x minus 3. When you find a vertical asymptote, you take the denominator, set it equal to 0, and that is your vertical asymptote. Horizontal asymptotes, there are 3 rules that deal with the degree of the numerator versus the degree of the denominator, and I've listed all 3 of those rules on the PowerPoint that I posted. In this case, the degree of the top is 2, the degree of the bottom is 1, 2 is greater than 1. So the degree of the top is greater than the degree of the bottom. Therefore, you have no horizontal asymptote. In number 17, I want to take that exponential expression or equation and turn it into log form. I take the exponent, set it equal to the word log. The base of the exponent is the base of the logarithm, and then 1 over 64 is what I'm taking the logarithm of. That's logarithm form for that exponential equation. Here, if I'm going to take this logarithm and expand it, what that means is I want to take that logarithm and it's kind of like distributing it to the numerator and denominator. And when I do that, since it is division, I would subtract them. The exponents will come down in front. So first, I would do log base 3 of x squared minus log base 3 of y to the 9th. Then those exponents come down in the front, and that would be the final answer. There's no math really to work out, you're just rewriting it. Number 19, since x is an exponent, I need to turn it into a logarithmic equation. That's what we did in number 17. So I start with the exponent, write the word log, the base of the exponent is the base of the logarithm, and then 5. Log base e is really ln. Take my calculator, find ln of 5, find that answer, then subtract 7, and you end up with a negative 5.39. Number 20 is the kind of like opposite of what number 19 is. My equation is in log form, so I need to turn it into exponent form. This number here that's alone is the exponent. This number is the base of the exponent. So 2 to the 5th equals x plus 8. So 32 equals x plus 8, and then subtract 8 from both sides. So x is 24. When you find the domain of a fraction, take the denominator and set it not equal to 0. So I get x is not equal to negative 4. So that means I can take any value for x, substitute it in, as long as I do not substitute negative 4 in. 22, you would hit stat enter on your calculator. Put this data in L1, x goes in L1, y goes in L2. Hit stat, arrow to calc, go to number 4, and that will give you a linear function, which is 2x plus 1. Here you can use your calculator, or you can use just algebra. Distribute the negative, and then combine like terms. And that was 10 plus 5i. Common denominator is 12, so I'm going to multiply by 12. Divide out the denominators, multiply the factors that are left. Since 6 is not a denominator, that's really 6 over 1, I just multiply 6 times 12. Now distribute, combine like terms, solve for x. And this is worked out on the PowerPoint that I posted. The answer ends up being x is 88 over 17. Number 25 is a compound inequality. I need to get x alone in the middle. So I would add 4 to both ends. I end up with 2x in the center, divide by 2, and I end up with 5 less than x less than 8. If I put that in interval notation, it would be 5, 8. To find the vertex of a parabola, this is in what's called vertex form. I take the opposite of what's inside the parentheses. I keep what's outside the parentheses the same. So the vertex of that parabola is 1, 5. To get the axis of symmetry, it's always x equals whatever the x coordinate is. To get the range, since this a value is -3, that means that parabola opens downward. So to get the range, I would put -infinity to 5. Domain is -infinity to +infinity. Any parabola has the domain of -infinity to +infinity. 27, to find the vertex, take the opposite of what's inside the parentheses, keep this number the same. So it's the opposite here, keep this number the same. Now notice this 3 out in front had nothing to do with the vertex. All that does is tell you something about the width and which way it opens. On number 28, if I want to know how much would be invested after 6 years, I would take 6 and substitute it in for x. And then put that in my calculator. And the answer is on the PowerPoint. It's also, let's see, it's $8,123.39. Since it's money, we round to 2 decimal places. Anytime you talk about something being initially invested, that means at time 0. So all you have to do is substitute 0 in place of t. and you end up with 5,500, which would be your initial investment, whatever number's here. I need to get the log alone, so divide by 5. Since this is a log problem, to solve it, I need to turn it into an exponential equation. Start with the base, raise it to the third power, equals 6x. So x equals 4/3. You cannot take the logarithm of a negative. You cannot take the logarithm of 0. So to find the domain, you take whatever you're finding the log of and set it greater than 0. So x is greater than 7/2, which would be 7/2 to infinity. Now the last page, I X'd this out. You do not have a page where you have to show your work. So hopefully this will help when you are getting ready to take your final exam.